The standard normal distribution has CDF f of x equal to, well, some function, and PDF, the probability that x is less than z, whose values have to be computed numerically. We can use a standard normal distribution table, but how many values would it need to contain? To that end, let's consider finding a relationship between f of a and f of negative a, where we'll assume that a is positive. So first note that f of a will be the area to the left of z equals a, while f of negative a will be to the area to the left of z equals negative a. Since the standard normal distribution is symmetric, note that the area to the left of z equals negative a is the same as the area to the right of z equals a. But this area will be 1 minus f of a, and so f of negative a will be 1 minus f of a, or their sum will be 1, which means we don't actually need the values of the standard normal distribution for negative values of z. So suppose x has a standard normal distribution and the CDF has values f of 1 and f of 2. Let's find the probability that x is greater than negative 1. We want the area to the right of z equals negative 1. By symmetry, this equals the area to the left of z equals 1, which is f of 1. And so the probability that x is greater than negative 1 is 0.84. We can also do that if we have a between interval. We want the area between z equals negative 2 and z equals negative 1. By symmetry, this will be the area between z equals 1 and z equals 2, which will be the area to the left of z equals 2, that's 0.98, from which we'll remove the area to the left of z equals 1, 0.84. And so that probability will be, or we might have something like this. So again, if we want to do this problem in as hard a way possible, we won't draw the graph. But we don't want to do that, so we'll continue to draw the graphs. The probability corresponds to the area between z equals negative 1 and 2. So this area will be the area to the left of z equals 2, which is f of 2, from which we'll remove the area to the left of z equals negative 1, which is f of negative 1. And so the probability is, except we don't have f of negative 1. Note that the probability z is less than or equal to negative 1 is the probability that z is greater than or equal to 1. And so that probability is, and since we do know f of 1, we have, and so we can find